Hello everyone. I would like to show you a proof for the Trapezoid Midsegment Theorem. And then after taking a look at that, I'd like to use the theorem in just a quick example. So the Trapezoid Midsegment Theorem, let's think about what we are given in this case. So our starting information is Mn is the midsegment, and let's say of trapezoid let's just call it A, B, C, D. Okay, and then the theorem, what it says and what we're trying to prove, there are two pieces to this. The theorem states that the midsegment is parallel to the two bases. So we want to prove that Mn is parallel to the two bases. Let's say AB, and so Mn is parallel, and then let's say the other base is CD. And we also want to show that it's equal to 1/2 the sum of the two bases. So Mn is equal to 1/2 when I add the two bases together. Basically, the length of the midsegment is the average of the two bases. All right, let's get a picture with this so we can make sense of it. Now, the way that I want to do this proof is we're actually going to do a coordinate proof. So I'm going to do this in the coordinate plane. And as long as I assign coordinates to everything in a careful, clever way, this should be pretty straightforward. So to make everything a little bit easier, I'm going to place one of the points along the x-axis here. And then so I'm going to place a point at the origin because the origin is really easy to use. And then one of the sides of our trapezoid, that will be along the x-axis. Just making everything a little bit easier to work with. All right, and then our other 2 points, we want these to be completely arbitrary. But since we are dealing with the trapezoid, by definition, we need to have the one pair of parallel sides. So we might as well make the parallel side to the x-axis, having a slope of 0. Okay, so let's say that this is A, B, C, D as our two bases, and then drawing in our midsegment, and then this is M and N. Okay, so the things that we want to show here, we want to show that Mn is parallel to the other two sides. And we also want to show that this length is equal to 1/2 of when I add AB and CD together. Okay, so I need to start labeling these so I can do my coordinate proof. So A, 0, 0, the origin, that one's nice and easy. B, so along the x-axis here, I just need to pick out some variable to use. And I think I'm just going to start with, let's just say A. And since it's on the x-axis, it has a value of a y value of 0. Okay, and then up here, D. So this it's not on the x-axis, it's not on the y-axis, so we just need two values here. So we'll say this is B and C. And then for our last point, let's see, how do we want to do this? We could do another variable. So let's say that this one, since I don't know the x value, let's say that its x value is D, but it does have the same y value because these are parallel to each other. So since this is a horizontal segment, this does have to have the same y value, so this is also C. Okay, now the first thing I need to do is I want to find the coordinates for m and n. And these are both midpoints. So so this is a midpoint. Formula for the midpoint, we add the x's together, divide by 2, add the y's together, divide by 2. So for AD, we got b plus 0 and c plus 0. So this is b over 2 and c over 2. And then for n, so add the x's, we have a plus d divided by 2, and then c plus 0 divided by 2. I'm just going to put that underneath here. So c over 2, and then this point, a plus d over 2, and c over 2. All right, so now that we have coordinates for everything, we can justify how we got those coordinates. Now we can go through and we can prove what we need to. So we got 3 things here. Let's start with our parallel. So to justify that these are parallel, we just need to compare their slopes. So why don't we go through and find the slope of all 3 of these segments. And we can do that with the slope formula. So AB to start with. So the slope of this, subtract our y's, so 0 minus 0, and then a minus 0. We get 0 over a, so we get a slope of 0. And we were expecting that. We put it along the x-axis on purpose, so we know it's horizontal, so it should have a slope of 0. Okay, let's take a look at the other base, CD. So the 2 y values, c minus c, and then the 2 x values, d minus b. So that's 0 divided by something, which is just 0. Okay, so we already knew that these are parallel to each other, so that works out. But then we're going to compare that to mn. So now we're using these 2 points. So the slope here, might want to include that. Okay, so the slope here, so we have the 2 y values, c over 2 minus c over 2. All right, it's already going to be 0 in the numerator, but we need to show the algebra. A plus, let's see, that was supposed to be d over 2 minus b over 2. So that gives us 0 divided by a plus d minus b all over 2. And again, it doesn't matter what's in the denominator. That's still equal to 0. So all the slopes are 0. They're all parallel to each other. So this is also parallel. All right, and now for the last bit, we just need to show their lengths. Okay, so we need to show that mn is half as big as the other 2 added together. Okay, so because we just found the slopes and we know that everything is horizontal, that actually makes finding the lengths very easy. We could use the distance formula, but because they're horizontal segments, we can actually just use the difference of the x values as their lengths. So for example, AB, going from 0 horizontally to get to B, that's just a difference of A units. So AB is equal to A. For CD, the length is just the difference between the 2 x values. So if I take D and I subtract B, whatever those happen to be, that would be how long that segment is. And then let's do the same thing for MN. So again, it's the difference of our 2 x values. So A plus D over 2, and then I need to subtract away the other x value of B over 2. We have a common denominator here, so this is A plus D minus B divided by 2. Okay, now I just need to justify this. So continue working with this. We can do some substitution that we see here. AB is the same as A, so we can substitute A for AB. And then D minus B here, that's the same as CD, divided by 2. And then if we want to rewrite this, this is the same as 1/2 AB plus CD. So Mn, carrying this down, we can see that that is equal to 1/2 the sum of the two. So coordinate proof, justifying what we wanted to there. So the theorem states that all three of these are parallel to each other and that the length of the midsegment is half of the sum of the two bases, or basically it's the average. And then really quickly, let's put that to use. So I just have a trapezoid. I know the length of the two bases. I want to find the length of the midsegment. So our theorem states that the midsegment is half as long as the two bases. So if I add the two bases together, cut that in half, that's how long my midsegment is. As I said, it's basically the average of the two. So it's going to be right smack dab in the middle. So this is 1/2 of, 40. So Mn is 20 inches long.